All right, let's go ahead and go over this one more problem. Following are the mean height of Kalama children, and the x. So this is kind of a horizontal table of values. The x represents their mean height at that age. So 18 months would be, 12 months to a year, so that would be 1.5 years old. And then their y values would be their height. Sketch a scatter plot. So of course I'm going to label age in months, and then the height in centimeters. And then I notice it ranges from 18 to 29. Now, if you want to show that there is a big gap, you can, but you don't need to in scatter plots. And then I see from 76 to about 80. So go with 20s. Then we just go ahead and graph these points. 1876, 1977, 2078, 2178.2, 2278, 2379.7, 2479, 2581, 2681.2, and 2781.8, 29, 83.5. Okay, so that's what my scatter plot looks like. And then if you actually use technology, I use this new calculator called Calculator X because I had some issues with getting the points on there. How did I get that? This is what my graph looks like. Again, if you don't, you'll notice my x-axis. If you can always manipulate data, right? There's a big gap. So again, I would just go under Stat, Edit, put it in my list there. And then to graph this, this one does a better job. Second, y equals to get stat plot. And then list X is my list 1 and Y is my list 2. So you change that on the top there. And then I wanted a scatter plot. And then you go over here and to the far right and just press graph. Okay, what is the correlation coefficient? Interpret in terms of the problem. So if I go back to my calculator, because I already have all the data in there. All right, I'm going to make sure, because I haven't used this one before, I'm going to make sure that the catalog diagnostic is on. So I'm going to, okay, put it back into the other calculator. Here we go. And the reason why this one has issues with graphing, just want to show you second, y equals, and then when you actually click on the first one where it says list 1, list 2, and actually they get L1 to be X's and L2 to be the Y list, you can't see anything in the column of X list and Y list, but they're actually, if you move your finger, you'll hear this dial, and actually you change it, but you can't see it. That's why I didn't like it. All right, so stat, calc, and we're calculating linreg. I'll use 5 on this one. Doing the home screen, let's try that again. Stat, calc, linreg, and then we just need to type in L1, L2. So second 1, comma, second L2. Okay. So there is our information. Let me take a picture of this. All right, let me make sure that I have all the information. Okay, so let's go ahead and go back. What is the correlation coefficient? So that's just basically a big fancy word for R. R is equal to 0.9943. Doesn't matter how many decimals you have, but you should have at least 2 or 3. What does this tell us? Is it positive or negative? Remember, this in some ways is your suds. Is it positive or negative? There is a positive. Is this weak, moderate, or strong? It is strong. Correlation. What are my two variables? Between age and height. Okay, so it says calculate and interpret the slope. So the slope was 0.634965. Remember, the word slope is the change of y over the change of x. So our y's were height and x was age. So we can say for every increase of 1 month, that's this bottom part here, the height, positive or negative, it's positive, increases by 0.634965 centimeters. And then let's go ahead and do I think we have the y-intercept up here. So what is the y-intercept? The y-intercept is equal to 64.9283. Remember, the y-intercept is in your linear regression line, and my line is bad because it's actually telling us that it's 64, which is like something way back here. So they're saying that's the best line to put it through. And sorry, the main idea I wanted to point is that you have a zero, an x value is 0, and then the y coordinate is 64.9. And what I want to point out is that we're talking about this part. Let's write that. When x equals 0, so that means 0 months, we would expect the child or baby to be 64.9283 centimeters. Okay, so to give you guys an idea, if you convert this, I'll just do the conversion for you. This is between 60, it's like 65 centimeters. In typical babies, my babies were about 20 inches. And 20 inches is about, I don't know, somewhere around like 40 centimeters. Some close, not exact, but gives you a ballpark idea. So these babies are like really tall when they're born. So you can say unusually tall. Okay, write a equation of the regression line. Okay. So our equation is going to be y hat, because that's a prediction, remember you can choose any form you want. So I have the slope, which was 0.634965, and then the y-intercept, which was 64.9283, and then if you want you can label what each of these are. I like to write it below. So the prediction of the height is a function of your age. Oops. So essentially what you have here is y hat is equal to their height, and x, is equal to their age. Okay. Last question. Predict the height of a 32-month-old child. So then you're just going to take this number, 32 months, and we're going to put it in here. Let's do that. So their predicted height is going to be 0.634965 times 32. Sorry, that was really messy. Plus 64.9283. And then if you, remember you're using PEMDAS here, guys. You're going to multiply these two, multiplication, and then add it to 64, the predicted height. The predicted height at 32 months would be, okay, so I'm going to write this in capitals, because remember in statistics we're not 100% sure, right? That's why I have this word approximately. 85.2 centimeters tall. All right, I want to capture a big idea, so let's graph this. Let's use red. I rarely use red. So this is the order pair 3285. 3285. Okay. Couple of questions. Are we super confident? It's pretty close to our scatter plot, but remember it is outside of this targeted window here. So that would be an extrapolation. Okay? I hope that was helpful. See you guys.